Hey guys, today we're going to be going over how to wire the analog inputs to the analog outputs on a V570 with the snap-in module. So we got the E4XB here, and we're going to go over how to configure this. So the first step is to program the software so you have your analog inputs and outputs working, so we'll do that. Alright, so now we'll go into our VisiLogic software for programming. We can go and make a new project here. And we'll have to make sure we select the correct hardware configuration. So this will pop up automatically. Just give me a minute. Here we are. So we're using the V570 in accordance with a V200-18-E4XB. They both use the same config for the E3 and E4XB. So in this, we'll want to configure our analog inputs and our analog outputs. So we can go ahead and we can use whatever we want for the input type, and we'll be using we'll use the 0 to 10 volt for this and assign this to MI0. We can label this as our analog input so we know what we're referring to. And we can go to the analog outputs here and select 0 to 10 volt as well, so that we're using the same thing. It's going to be our analog outputs. Okay, so we're just going to keep it simple, and basically the scaling for these devices. One sec. So here we are. This is where you can find the user guides for our devices. We're in the snap-in module section. We'll select the E4XB over here. And if you scroll all the way down, you can go over to the analog input section. You can see the resolution range. So this can be set to 14-bit. It can also be set to 12-bit depending on what you put in the hardware configuration. We have it set to 12-bit on the analog inputs. So 12-bit is going to be from 0 to 495. And the 14-bit is going to be from 0 to 1380383. So you'll have to linearize your inputs corresponding to that. And if we go to the analog outputs down here, this one is a 12-bit outputs from 0 to 495, being the 10 volts. Alright, so now we'll set up our HMI so that we can input the analog output value on the HMI itself. So we'll go over to the numeric box section and we'll add a numeric box so that we can input the value. So to do that, we'll first have to link an MI. So we can link this as our analog keypad value. And so we can enable the keypad entry here. And we can set a min and max value just so that the user can't input anything that is out of range. So it will be 0 to 10 volts. And we'll use a linearization block in our ladder to scale this. So we can just do this on every scan, or we can just wait for a legal entry to do the linearization. We can just set this up as a legal entry here, and so we'll do that linearization just whenever the value changes on the HMI entry. So we set this up MB0, and we'll set this up as a positive transition. Alright, so now we'll get our linearization function block from under the mass section. Linearization, here we are. And we'll have to set our x1, y1, x2, y2 values. So if we go over to the user guide, we can check the analog output section, and we can see that it's a 12-bit resolution on the output. So this is 0 to 495. 495 will correspond to our 10-volt output. So let's go back over to the VisiLogic software. And our input value for x variable will be the voltage. So we'll have a 0 voltage. And 0 voltage corresponds to 0 units. And a voltage of 10 corresponds with 4,095 units. Just like that. The input value is the keypad entry on the HMI. Let's go down here, analog keypad value. And the result is going to be stored in our analog outputs. MI1. So that's good. Alright, so now we'll grab our linearization block under the math section. Math, linearization. And so you'll see we have the x1, y1, x2, y2. And so basically we're going to be taking a value of 0 volts, mapping it to 0 as the units as well. And we're going to take a value of 10 volts, and that's going to map to 16383, which corresponds to our 14-bit resolution max value. So we'll take, this is x1 right here, we'll just do a constant, so 0 volts, and then that'll correspond to 0 units. And so we'll take x2, 10 volts, correspond to 16838, or we'll double check that here in the calculator, 16383 as our units. And go ahead and do that. So our input value is our keypad entry. We can go ahead and click this, find that variable we linked. Let's be the analog keypad value, which was MI3 or MI2. And we can link this right to our analog output. So that will be the results, is what we want to output on the analog outputs. Okay, and that is good. So now we can enter a value in the HMI and see the results, and we may as well link the analog inputs to the HMI as well. Do that with a numeric box here, and we can spice up the HMI, but this is just going to be a practical tutorial here, so we're just going to link the analog input just like this. That is good. All right, now we'll download this program to the controller and go from there. Alright, so before we go ahead and wire everything, we're going to want to check the jumper settings on the actual snap-in I/O. You can see that jumpers 3 through 14 are for your analog inputs, and that each input has 3 jumpers that correspond to the type of input. So for our case, we're just going to want to make sure analog input 0 is set to all A's for voltage, and the analog output 0 is set to B for voltage. Alright, so to access the jumper settings, you're going to need to unscrew this top control screw. Take that out once you've unscrewed it, and flip it over to the back side. So the back side is where we'll see the jumper settings. So basically over here, let's flip this around. Over here on the left hand side, this is where our jumpers 3 through 14 are located, and you can see at the very bottom, that's analog input 0, and it needs to be switched. So to the left is A, and to the right is B. So we need to switch that first one to be A. Alright, so we switch that over, nice and good. Those are all set to A, and we can go over to the analog output section over here. You see these top 4, 1, 2, 3, 4, and looks like they're all set on the B position, which is the factory default already for voltage, so that's all set. Alright, so now that we've programmed our controller, now comes the fun part, which is wiring the actual device. So if we look at the user guide, we can take a look and see that the analog I/O requires its own power supply. So in addition to the power source to the controller, you're going to want a 24 volt DC to the 0V and VA. So we'll take note of that, so make sure we can wire that up. We'll do that now actually. Alright, so we have the snap-in device here, and we can see that the 0V right here and VA need a power supply. So we can use share the power supply with the actual controller power supply, so I'll show you how that looks. Alright, so we went ahead and used a red color wire for the positive which maps right to the VA, and then a white wire for the negative, which maps to the 0V. Alright, so now we'll go ahead and actually wire the analog output to the analog inputs. You can see the wiring diagram here. You see that you'll put the outputs, we'll have our positive lead coming out of A out 0. We'll also have a lead tied to the common. And on our input side, we'll take that positive lead right into the analog input 0 positive, and we'll have the common tied to the ACM over here. Alright, so now you can see that we have the A out 0 as a red wire going into the T plus on the analog input side, and we have the common wire as a white wire going into the ACM on the analog input side. So if we go ahead and flip these PLC so we can see the HMI for a second here. Alright, so now we can see on the HMI an output of 0, it's getting us 0 volts back on the inputs. We can try half the range at 5. You can see that we get a value of 2047 because the input range is set to 12 bits. So it is also scaled to 4095 at the max. We can see that when we change this to 10. We could also set up some linearization for the inputs, but this is going to be it for this demonstration. Hopefully you guys learned something.